Hello, everybody.
Well,
Okay, I'll just share my screen. Give me 1 second. Let me get because there will be sound.
you can share sound as well, can't you?
Yeah. Yep. Share sound. That should do it. Okay.
And spotlight you as well.
Okay. Everybody can see my screen, right?
Yep.
Perfect.
So music with IoT.
Awesome. Well, thank you very much, Richard. Really appreciate having me at your meetup. I've been a big fan of this meetup group and very excited to talk to you, to everyone today about making music with IoT. So let me hide this so it doesn't take screen. Um, I'm Suyash. I am a software engineer, creative technologist. Last year, I completed my master's degree here at Goldsmiths, University of London in game design. And before that, I was working for quite a few years in San Francisco Bay Area before moving to London as an engineer and got my undergrad degree from University of Michigan. And I really am a big fan of Raspberry Pi. I have a bunch of them, and I also got certified to teach and often teach workshop for children. When I'm not coding, I love to perform magic tricks as well. And I've also combined my two passion, and I've also created a magic trick with actually Arduino, but that's for another day. Because today we're gonna focus on the music side of things. So I'll show you two different projects. It would have been great to show you all of these things live, but I'll show you. I'll briefly show you through the camera because my room is a mess. But we'll go over the slide and you'll see my screen and things like that. So the first one is going to be with Arduino. Arduino, as you are, I'm sure, aware, it's a microcontroller instead of a full-on computer. It's smaller, cheaper, and it is actually quite powerful. Not as powerful as Raspberry Pi, of course, but in its own right, it can do a lot. There is one particular project, it has gone viral for many years now on the internet, or I should say, I guess it's very popular online, and especially for children to basically encourage them or showcase coding to them. So here, what you're seeing is a board, and I'll turn on my camera, I'll show you live. It's a board connected to different fruits, and when you touch on any of these fruits, they would make some kind of a sound. Generally, they make like a drum machine sound. So this project is called Fruit Drum Machine. I will actually let me just share my. I will turn my camera down. So pardon my room and everything here is kind of a mess, but if you can see, if you can see what I have here, let me make sure I have the right, sorry, software running because I need another software in the background. And okay, that's on now. So so I'm on my laptop. I'm gonna put this camera so you can see it below what I have here, the contraption. And I have a very small fruits right now because limited space right now. So here, uh, by the way, this is my Pi with the display. Uh, you can see here it has a different board, like a Sense hat on it. But right now I want to show you this thing. So this is Adafruit's board. It's called Circuit Playground. It is a really good, nice board because it has a bunch of sensors. And I've connected a few of these pins with the alligator cables here, as you can see. And then I've connected it to, guess what? A raspberry here and a blueberry here. So they are, this green one is right here, and there's the red one, and then there is a yellow one, which I've not connected because I want to show you what this thing does. So if I touch on any of these, you probably can hear some sound, right?
No, can't hear anything.
You're not hearing the sound?
No. If you I think when you share, there's a little box of text saying share share
Yeah, I
sound.
did that. I did that. I guess, because I'm not trying to share any screen. I just want to share the sound. It's already checked.
Okay.
I guess it's forcing me to share a screen, and I think cannot share the sound without it. So, all right. Well, you're gonna look at the screen, but I'm also have my camera on. So just make where you see my camera, just make that bigger. Ignore my desktop. Um, and if you can see, if you can see, I suppose you can hear it, right? Richard, can you
Oh,
confirm?
can hear a little bit. It's not
Okay,
very.
a little bit. It's not very loud. Let me turn on. Let's see.
I mean, if it's just picking up your voice, it should be. It's going to the same mic as your voice, is it?
Do you hear like a drum sound?
No, I don't know if anyone else can.
Not hearing it. That's unfortunate. Um, mm. Don't know. It's a challenge with Zoom. Um, let me try to share. There is a share sound. I have it checked.
You just turn up the volume on your application.
Yeah, it's maxed out, and I'll max it here as well.
I can see it's doing something there. Yeah, it's picking it up.
Okay. Well,
What if you
mm,
just play it back to us? So we record something and play it back to us. Maybe that'll work.
play it back. Mm, 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 mm. Mm. Yeah, that would be hard because I can do it on my phone. I can just show you a video. Let me just, maybe we
Okay.
can look at a video. Sorry about that. I didn't realize let's see, select the speaker. Oh, okay. Uh, select the microphone. Uh, audio settings. Let me do this. Okay. Still nothing, huh? Okay. So, hmm, output volume, nothing. You still don't hear it?
No, maybe stop the share, then try sharing again. I don't know if that's going to help, but might.
Mhm. L- Let me see if anybody in the chat. Okay, no. Uh, well, I guess I would play a video. I'll show you a YouTube video. I have exact same thing going on, and I'll explain what the difference is on my end. But
Yeah.
at least you'll have an idea of what I'm talking about. And then there is another software we're going to use, Sonic Pi. I hope that will come through because that is one is critical. So can you connect Arduino output to microphone? Actually, Arduino output is through the computer because Arduino doesn't have speaker. But let me play the video. Let me play a video. So, or let me explain it. Let me just play the video. Okay. So let's do this. Let's do this. Oh, there it is. There it is. There it is. There it is. So, what
That's working.
so that's the project basically. It's very simple. I encourage you to play with this, make this. Children really like it. I mean, everybody. I mean, when I first saw it, I instantly wanted to make this. All you need is you don't even need to have this particular board. As you can see, a lot of different YouTube examples. All you need is basically a capacitance touch sensor to detect touch. Um, like here in this example. So they're touching something like this is probably conductive tape or something like that. And then it capacitance touch, it just basically detects change in the capacitance and then it sends that value. So let me get back to the slides now. And I'm using this board, and this board has many sensors. On the edge, you can see the holes. Those are basically your GPIO pins. And the ones where I've attached alligator cables are numbered pins, basically. And these alligator cables, on the other end, they are attached to the fruit. So then it can detect any kind of a touch because these pins are actually capacitive. They're built-in capacitive touch sensors. So alligator pin just conducts that current from the fruit. Basically, the fruit detects when I touch it and it changes the value of the capacitance, and that change is recorded. And at a certain point, I create a threshold. So I detect that change when it meets a certain threshold. And when it does, then I send it to my computer. So one thing to note, somebody was asking in the chat, this board also has a tiny speaker. So you can play sound on the board itself, but it's a very tiny speaker, doesn't sound anywhere close to what we heard before. So the way I do it is because the Arduino is connected to my computer, I detect uh, I detect MIDI signal. So I'm using MIDI, which is another library for Arduino. It's for music. I guess it stands for music interface something. Basically, it communicates music electronically. So this is essentially what is happening. So the alligator cables here, they're just connected to this cardboard with, like what looks like a piano keys. In my case, I've just stuck them to the fruits themselves. And all of them are mapped to a MIDI value. MIDI values on the table you can see on the left, and they correspond to an actual drum sound. So different instrument, bass drum, snare, hi-hat, open hi-hat, toms, it different value correspond to different instruments. So they produce that sound. Go to the next slide. So here I've list down step-by-step steps, so make it easier, and then I'll show you the code as well. So initialize the Arduino environment, make sure you have your fruits connected, and in the code, you would map the pins to which you have connected the fruits, basically, using the alligator cables. In this case, it says connect speakers or piezo elements for sound output. Ignore this. In my case, I'm just using MIDI to do that. And then your code, all it's doing, it's detecting touch. It's detecting touch at a certain threshold value. And when that happens, it detects which pin it was touched. And then that pin number is mapped to a corresponding MIDI drum value, like we saw in this table. So if pin number 5 was touched at a certain threshold, then we trigger 39, which is a close hi-hat. And that 39, the close hi-hat, it's played. In my case, I play it from a software called GarageBand, which comes free on any Apple computer. So, or you can use different um, digital audio workstation, or you can just write music in code as well by creating oscillators and things like that. But it's way too complicated. So here, what I've done is save this. So when you open GarageBand, you can drop any instrument. So for example, you can do a electronic, and here we can uh, all you have to do is settings. Yeah. So in your GarageBand, all you have to do is you go under audio and you change the MIDI controller. So in my case, uh, it's detecting. It should be. Sorry, let me go back to my existing project. Basically, the input is the MIDI. It's coming from the MIDI because actually, sorry, it's here, not the device input. It says to MIDI controller. This is basically our Arduino. So because this instrument, it receives MIDI signal, and the MIDI signal comes from Arduino. So sorry, I'm jumping around a little bit, but I just want to explain you the whole flow. Um, and I'll pause after this and I'll take questions. So you connect the Arduino um, with the DAW, which produces the sound, and the Arduino code has the corresponding code to map when the pin detects the touch at a certain threshold to a MIDI note. Uh, and yep, here I've just explained all that. I used ChatGPT to give me a step-by-step explanation of the code. But let me just explain you the code as I walk you through it. So here's the Arduino code. First of all, we import the necessary libraries. It's connected to this board, like I'm using Adafruit Circuit Playground board, and at this port, right? So that's the first thing when you plug in Arduino, you want to make sure that's there. Then you want to import the correct libraries. You want to install them in your Arduino IDE and then import them. So one of them is for MIDI, other one is specific to this board. And then I define certain variables. One is for threshold, the other is for debounce. Threshold is basically when I touch the fruit, it detects signal. I don't want it to be triggered anytime. Well, actually, when I don't even touch it, there's always certain change. These sensors are not 100% accurate, so they're fluctuating. So I create a threshold value because I want to make sure when my hand touches it, not it's on the table or anything like that, I don't want it to get triggered. So I set a threshold value. I played with this value. It's set to 1015. Debounce is when I remove my hand, I want it to stop, and then I touch again, I want it to play. So it acts as a little pause, you can say. So that is set to 100 milliseconds. And I define the pins for the various pads and the number of pads here. The main code is in this switch case statement inside take action function, where I'm detecting which pin was touched. And I print certain value, basically the MIDI note, and I send that to another function with that corresponding note. So let's go to drum hit. And drum hit, what I do is I use the MIDI library now to send MIDI value. So MIDI is a certain format. So one is the channel is 9. So MIDI is an interface. So you can play piano sounds, you can play drum sound. 9 is the channel for drum sounds, basically, in MIDI world. And then velocity is 125. It's how fast when you push the key. So this is the standard. I've set to 125, and it gets turned on and then gets turned off. So when you touch it, because it just sends one signal essentially. MIDI note on and off is what they call it MIDI terminology. And that's it. Then there is just a loop that is just a infinite loop that's running the code, and it's detecting anytime I touch any of these pads. I will stop here, and I will like to take any questions because we're going to go to another piece of demo. Anybody has any questions, or I will stop this and I'll look in the chat as well.
Yeah, I was wondering, can you detect the velocity from the fruit somehow?
Velocity from the fruits.
Yeah,
That's a good point. I do it through the debounce logic, because if I reduce the value of the debounce, it'll be like it'll detect multiple touch points. Yeah, MIDI, I think MIDI velocity, I need to Google. I think it means slightly something different. To be honest with
yes.
you, I'm not 100% like a music like expert, so I'm also new to the music.
Yeah, I know when yeah, my child plays piano and then always talking about the velocity at which you hit the key, that determines how loud the sound gets.
I think that's what it is.
So I wasn't sure if you can somehow use the capacitive touch to get some aspect of
Oh, I
velocity,
see.
so you're not
I
just like
see.
always playing the same, the
I see
same
what you're
drum beat,
saying. I see what you're saying.
the same volume.
I see what you're saying. Yeah, the intensity of the touch. Yeah,
Yeah,
that would be a nice that I will note that down. That would be a fun to play with. Right now with I just when I do it, I put orange apple, so I don't want them to squeeze on them too hard, just touch them. But for certain, you can have a different thing, and it could be, yeah, how much you're touching it. That could be mapped to a MIDI velocity, especially for a piano. It would make more sense because the note goes up and down. Um,
one thing
yeah,
I did a while ago was I connected accelerometer to a Raspberry Pi, and then you can detect how hard something's being hit. So
yep,
you could change it a bit. We could have both. Couldn't you have capacitive touch? Then you could have like a hammer and a piece of board that you could to really give it a strong hit or something like that. Pick up the accelerometer, and that would give you the velocity of the hit or the strength of the hit.
absolutely. AC asks, can you play more than one sensor simultaneously at a time? It's a good point. I haven't tried it. No, so I just touched it. Sorry, the voice sound is not coming, but I am just kind of like playing it right now. I don't hear them simultaneously. I hear one and the other. I think it could be because of because either the debounce logic or something, but it right after the other, I'm hearing two different, like basically drum sounds when I try to touch them together. So no, right now, but be a good question because yeah, that would another thing to experiment. Any other should the player well these are copper boots. Where I don't know what the wellies means, but
Rubber
copper.
boots. That means rubber boots. So how does the capacitive touch sensor work? When you touch it, does it kind of add to the capacitance, in which case you probably want to wear wellies? Or is it to short out the sensor to ground, in which case you should wear copper beads?
Yeah, it's something to try. Yeah, it's something to try. It just
You know,
detects the
oh,
change in capacitance,
yeah, I
but
was just wondering
yeah,
which way it goes, whether it creates capacitance or whether it shorts it out. Yeah,
yeah,
don't
yeah,
know.
something to experiment. Yeah. Um, a jamming, this is the next tool. Let's dive into that. This is the perfect tool for jamming. So let's move on to Raspberry Pi. I think this one, I encourage you to, after this talk, like play with this down because you can download on your computer. I'll show you on my computer. But you can run this on the Pi as well. So, so Sonic Pi, for those who haven't heard of it, those who have, please feel free to share your experience, anything that comes to your mind in the chat, and I'll take it later. But for those who don't know, it's a tool created by Sam Aaron. He is also a creative coder, musician, and he performs live. And when people do this performance, they call it live coding for whatever reason they choose that name, very generic name. But so I'll just play a little video of Sam. Oops, why isn't it go to the video? I hope you can. Oh, it's gonna start an ad. I hope you're hearing the sound from YouTube.
Yeah.
Um,
Can hear it. Yeah.
okay, great. You will see this thing performed like what looks like a nightclub. So what people do is almost like, yeah, performing in a nightclub like a DJ would. They bring their computer, they open the software, connect it to a projector, and they start live coding. So I want to play this from the start, but I guess I'll just let it play for sake of time and have a look at the screen, see what you can see and hear. So as you saw, it is environment where you're writing some code, music is being generated. The pretty visuals, that's not Sonic Pi. I don't know how he's doing that, but that's a different software. So Sonic Pi, actually, I believe comes installed with the Raspberry Pi now. If not, then you can go to Sonic Pi library, sonicpi.net, its website, and you can download it. It comes in its own IDE. You can see the picture on the left. That's kind of what it looks like. It has an environment where you write the code, run the code, and the nice thing, it has also documentation baked into this IDE. So it's an MIT licensed software. The language you see here, it's Ruby, and it's built on top of some other softwares, some more fancy music making tools like Super Collider. And on the back, it's running a server which is communicating with Super Collider, which is essentially what is creating the real-time music making tool. Sonic Pi is, you can say, the UI interface at the top of it. But because it uses Ruby, it's a language that is easy to learn, easy to read, and it's very popular again with children, getting them into coding through making music. And it's very English-like, the APIs as well. So I'll just explain you some of the concepts and then we're gonna go right into it live. So I'm also new to music world, And a lot of these things are, if you do any kind of electronic music, you know them. Synth is something like a virtual synthesizer. Basically, this is your instrument. Like, in GarageBand, we play drum sound, so it's a drum synthesizer. It can generate that sound. And here, in this case, the code is on the right side column under example code. So you would write something like use_synth saw, which basically means it's a certain type of oscillator or a wave, sawtooth wave that we are creating for the synthesizer. It's slightly low level, slightly higher level. You want to play with samples. Samples are already pre-recorded sounds that you can trigger. So in this sample code, you start with drum, heavy kick. And these samples already come in the IDE, so you don't have to download it, anything like that. You can also play music notes. So C4, which would play the middle C that you might see on the piano. Duration, you can change the duration. How long should it play that note for? In this case, it's 2 beats. So you might wonder, why is it not seconds? Well, timing and music, especially with computer music, it's a tricky topic. So the program by default works on, it is set at 60 beats per minute. So essentially, 2 beats would be 2 seconds. So 1 beat per second. So you can change that configuration, but default is 60 beats per minute. Then the more interesting way to make music is by loops, by creating these loops or live loop. And that's where I think the live coding really shines. So this music, it runs in a computer loop that is looping that, it could be a drum sound or some other beat, in this case, like a snare drum. Then we set a sleep one. One is 1 beat. So because computer, we need to add sleep as well, um, uh, from a music point of view as well. So you can hear it's not just constantly going, but you can hear that beat. There's a sleep, and then beats again. So if it's a loop, infinite loop, it'll keep going on and on. Play just plays. 60 is the MIDI value. In this case, it mapped to C4 or middle C. So you just type play and then pass it the MIDI value. Or you can type in play C4 if you want to provide that notation, the notes notation. You can add effects to music. So you can add reverb effects. They're variables, of course, because a programming language, you can create variables, functions. You can set a tempo. So if you want to play a different type of electronic music, fast-paced, you can change the tempo to play it at 120, in this case, beats per minute. And this software can play many instruments at the same time using concurrency. So you can spawn threads and play different instruments using different threads or different pieces of music. And like any other programming language, it has standard, your control structure, if else loops. And then the live loop we covered, it's just it's like a loop that loops around. So let's have a look at this. So I will first just show you the website, Sonic Pi. Sonic Pi, this is its website, and you can download on your Windows, Mac, or Raspberry Pi. And you don't need anything else. And then you can just you open this IDE, the software, and you can start coding. So I have it right here on my Mac. And this is what it looks like. So this is where you type the code. So for example, I'll just type this and I'll hit the run button. Richard, did you hear that sound?
Yeah.
Okay, great. So this was critical. I'm glad this is working. So here we can play the middle C or whichever 60 stands for. So the nice thing is that it has on the left side, you can see its log. It shows you its log. It is also showing me my Arduino board that is connected. But here, let's play a saw wave. So we'll just copy paste to save time. These are all examples that you can play. And all you do is just hit run. So it plays note 38, sleeps for 0.25 of a beat, plays a different note, sleep. So we have made a little small tune, and the tune is being played using a different we can play it at a different so you can play using a different synthesizer. So you can change it. So it's playing the same tune, but using a different, you can say, instrument or a synthesizer, right? You can manipulate that sound further by changing its amplitude, its attack ADSR envelope, basically. So let's copy this line. So this is changing basically the envelope. So they call it ADSR attack.
And we're not hearing that sound anymore. I don't know what happened?
It was not that loud. It's kind of like I can.
Oh, can just barely hear it.
I barely hear it. Okay. So it, I think,
Yeah, okay.
okay. I'll play a different one. So just to see visually, attack is how the sound starts, then it grows, then how it sustains, and then how it, in the end, kind of like you can say fade away. So you can change this envelope by, in a GarageBand or different music tool, you can actually drag and change these. But here, of course, because we're writing code, you can change the float values. Now, the fun thing is that we have samples. So we have pre-recorded sounds. And we can play these. So a lunar landing type of sound and then a droney sound. And again, you can play it, change its various parameters, add pauses, etc. Stretching samples. So looks like a vocal, I guess, at a certain rate. Oh no, it's a loop. It's a drum loop. Tell me if would have to speak up. You can change the rate. You can change the rate at which it plays. This one is fun one. What this one does, it basically plays it in reverse if you put a negative value, negative wave. So it plays backward. So, you can do something fun like you can go on YouTube and find like some audio recording, and when you play backward, they reveal a secret message. So you can have fun, something like that. You can record something that in backward you can reveal a secret message. I would love to do something like that for a magic trick. Um, but here you can read more about the sample rate, etc., that you're controlling. So it has really good documentations. I'll just play some examples. So a live loop is essentially with some effects and whatnot. Really, really.
Yeah, I can't really hear that very well.
You cannot hear that one. Okay, so let me play.
Not very well, anyways.
Not very well. Yeah, it was too fast also. Let's see if this one comes through. Another one.
Yeah, I can hear that one much better than the previous ones.
Right. So I was trying to live jam. So this is how you would mess with it. So you would forget yeah, there it is. So you would, let me make sure how you put the comment in Ruby. I guess is that one. Nope. There's some different.
Probably ampersand,
It's ampersand.
but ampersand hash.
Hash. Hash. Hash. Oh, okay. Let's Google quickly. Oh, okay, it is hash. It is hash. So I guess that did comment out, but I was hearing that. Let's do this again. Yeah. No, that didn't. That didn't.
It's weird.
Oh, okay. One. Okay, so they've made it slightly different because with live coding music, they want to type as less amount of keys as possible because they're live performing music. So yeah. So this one, I guess the key plus will torment. Mm-mm-mm. So this is a nice helpful cheat sheet as well. Code. Yeah. Anyways, I'll leave you with this cheat sheet. This is a nice cheat sheet because you can run all of this by keyboard. So you can change a line, you can run it, you can comment it. You don't have to go to the mouse and press these. But yeah, this is where you would do jamming, or live performing. Maybe even with somebody else. Somebody else could be live singing, and you can play any kind of instrument. It's almost like you have a synthesizer, but through code. You're instead of turning knobs and things like that, you're writing code and manipulating that music piece. So I encourage you to play with this. There's oscilloscope, and there are other details about, like, if you really want to dig down into all the things that it does. So here, for example, how you create a different thread. Um, the heart of it is basically loops. Loops are the key in this one. So you essentially you're playing a loop, and you're generally then you're manipulating different parameters of the sound, and then you can bring in different instruments and whatnot, but everything happens inside a loop. um, and then you can add different effects and things like that. There are different, of course, different types of sound. If you want to play a chord and things like that, you can of course play that. If you so Just quickly paste this one. Oops. Or mm, 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 mm. Of course. So you can, if you play piano, you would be more familiar with music than myself. So you can come here and play different tunes and whatnot. I like the sound of drums, more electronic music. So I love to make little beats with this thing. And there is a lot that you can do. So they have a lot of these examples. You can even make something using for Minecraft. But because it's all programming and it's all on the Pi, I'd like to share some other examples of what people have done. So we go back to slides quickly. So somebody here has connected, guess what? An Arduino with Sonic Pi. Um, and here he's detecting every time. Let me just play it for you and you'll see what's happening. It's audio and visual, like a little DJ. So every time a note is played, the light turns on. And he has mapped different lights for, I guess, different notes. And you have a little audio visual effect. Isn't that pretty fun? You can make your own like a night, like a disco light that it reacts to music, audio reactive lights, basically. Another really fun example, slightly different take on this thing. So here, this is what looks like a Raspberry Pi screen powered by a Pi, and you can see Sonic Pi code right there connected to this keyboard. And there is a different hat here. So this is example from Adafruit. They're using a different hat to connect to these. On the right, you'll see these knobs. So you can actually now change the value using these analog controllers. So I hope this gives you some idea of the possibilities. One thing that comes to my mind when I see this is you can make your own music instrument, right? Because imagine if, you hide the keyboard or you don't need the keyboard, if everything is connected to the analog controller and the program is running, because he somehow, I don't know how this person has done it, but he has mapped certain parameters to the analog dials, and he's controlling it through that. So it's kind of like your own instrument, uh, using which you are, creating different sounds. So let's go to next. Thank you very much for listening. Here are the links to various things I shared today. Essentially, we talked about two different things. One is what I would say procedurally creating music, which is using Arduino, where you've written the code like any program, and it's connected. In our case, we saw to fruits, and the code is there, and it sends it's also a real-time instrument, but it's not live coding in the sense you're changing the values and it's not stopping the program. The program is running and you can control and you can change, just like you would do in an analog, like a synthesizer or digital synthesizer. So, so we saw live coding and non-live coding way to make music using two different IoT devices. Um, I also run this meetup group. I just started, and you're welcome to join this as well. I hope to share more things around creative coding with music, coding to make art and things. And I also duplicated Richard's event here for today. So if you came from that meetup, welcome as well. And if you have any question, you can reach out to me. And I'd love to stop here, take any questions, and we can just chat.
Yeah. So in Sonic Pi, do you have full access to the language, or can you only use it just for making sounds and stuff like that? Like you can actually like connect to external devices connected to your computer or your Pi?
That's a great
What's-
question. I haven't. Let's just Google that right now. Let me share the screen because that's a great question.
So I
Because
wasn't sure how they're doing
it is it is a subset of Ruby. So, uh, so yes, so looks like you can link Sonic Pi as a library, and if you're writing code in Python, let's say to connect to or do anything with the Raspberry Pi, you can install. There you go. So Sonic Pi also has a Python interface. So then you can you can run it in Python environment. And from Python, you can do anything, I suppose, if you're trying to do anything with the Raspberry Pi itself. Uh,
right.
uh,
So you could theoretically connect to your Twitter account and play different music based on how many tweets you're seeing or something like that.
yes, exactly, exactly. You can do all kind of possibilities open up. Uh, I'm seeing if Sonic Pi itself has a like API or way to access the Raspberry Pi. Uh, Something to be researched. There is some stuff, but it has a thriving community. Um, so this this there's some people have done some stuff, but yeah, seems to be it seems to be possible.
And when you're dealing with children, how do they take to this? Like, which do they prefer? Do they prefer the Sonic Pi or do they prefer the?
Yeah, the children prefer, I guess. So I've done it for very little children. Them, they just want to touch the fruit and make music, and they're happy with that. But slightly older children who are into coding, yeah, no, they love coding. So, matter of fact, I'm running a workshop tomorrow at a library here in London, in East London. We're gonna do some live coding with Sonic Pi. So yeah, when you have music, they love, but sometimes it becomes hard to control because I show them a little bit and they start playing with it and they just go in their own world. So yeah, but those who have gotten hang of a little programming, text-based programming, not Scratch, they really like it because a lot of programming doesn't involve music.
Yeah. And what other things have you done with children? It's just interested in how you. It's
Yeah,
always been how do you like choose a project that's sort of suitable for kids?
just make little tunes of popular music, popular children's music, popular tunes, just code them up, and then one thing I try to do is like change the synthesizer. So maybe something in a sound like, of a hand clap or a tortoise with singing that tune. Um, what does that mean? Then we go deeper into how is this creating the sound? And then how are we doing these things parallelly? I talk about a little parallel, like how are we running different instruments at the same time? So they learn a little bit concepts of computer science, the coding itself, and then they're also learning some music knowledge as well. So it there's a material also. So this was also built in collaboration with the Raspberry Pi Foundation. So they have also have created a lot of material to help promote Pi in education. I can
When's your next meetup? Do you have one planned?
We don't have one plan, but I hope to do it end of June or early July. We'll do something. And Richard, I'll share with you there is a location I found which is open to all kind of meetups in London,
Uh,
and it's free. So it's a little bit not in the central London, but it's a hacker space, and they're welcoming to tech, people who are doing
yeah,
meetups. So hope to
very
do
cool.
something there. If more people are interested in there, we can have like a little jam, or you can perform. Everybody get a few minutes to perform something. Yeah. Any other questions anybody has, you can just say, I guess, speak or chat in the chat. Um, but yeah, sorry, the audio wasn't clear, and especially with the Arduino thing, you couldn't hear it. But I'll bring it
Yeah, it's very
at the
cool.
teacher meetup. Happy to just show it, and we can have a play at it. Somebody said
Very
MIDI
cool.
interface for a daughter. That's awesome. Yes, so you can get the Akai. I have the MPK, like a MIDI, like a keyboard. That one is great. Or you can make your own with Arduino, and it's fun. But yeah, it's great way to introduce music. You don't have to have a big piano. Uh, Somebody explained the capacitance, how it works. That's great. Yep, I think that's it.
Any other questions from anyone? Somebody asking what type of Arduino you're using?
I'm using I'll share the screen again. I'm using let me just go to the slide. I have a link to that. Da, 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 da. So the fruit example, it's here. It's by Adafruit. This company, they make their own boards which are Arduino compatible. So it's their own board. So as you can see, it has lights. It's a really good board. If you want to get one board and have somebody learn Arduino, I would get this one. Arduino standard is good as well, but this one has accelerometer, so you can rotate it around. It has lights. It has buttons. You can push buttons, and the edges it has the touch sensors. So it has a lot of these things to play with, even a little speaker. Uh, I think piezo speaker, even a microphone. There we go. So the photo. So it's a good board, not too expensive, out of stock, but they have a new one called the Express one. Uh, I think it's this one. So they have a so it's Arduino compatible. So the code here, this is an Arduino code, right? C, but it is uh, it is Arduino compatible board. So you can write Arduino code, but of course you have to, if you want to use the sensors or detect the pins, you have to use this library. But it is, yeah. So Adafruit makes their own board. I mean, they can be a little expensive, but they put really nice documentation. So I like them. But yeah, Arduino also, I'm sure, has I think some people mention there is another fruit machine. There is another board. I mean, if you search the project has become so popular that that you can, I'm sure, do it with Arduino as well. But you just have to have the capacitance for touch sensors, and you have to get its library or something like that. But yeah. It's Arduino like, not Arduino the board.
Very cool. Any final questions? Yeah. Okay, thanks very much. That was really cool. It's very interesting.
Thank you.
Good luck with your dealing with the children.
Thank you. Yep.